Boston Dynamics Atlas weighs 80 kilograms. The robot stands as the benchmark for humanoid robotics, but a new competitor just emerged. The Phybot M1 weighs less than 60 kilograms and features 32 degrees of freedom. This is 28% lighter than Atlas, while delivering what the company claims is superhuman strength. The question is not whether humanoid robots are advancing. The question is whether this specific robot can challenge Boston Dynamics' dominance. Let's start with the Phybot C1, companion humanoid. This robot flew under the radar until recently. The C1 features a projector screen built into the face. This represents a new feature not seen in commercial humanoids previously. The robot stands approximately 128 centimeters tall, or 4 feet 2 inches. It weighs 28 kilograms, or about 62 pounds. The C1 has dimensions similar to a larger child rather than an adult human. The C1 features 25 degrees of freedom across its body. 2 degrees of freedom exist in the head for pan and tilt movements, 5 degrees of freedom per arm, cover, shoulders and elbows and wrists. 1 degree of freedom in the waist allows rotation. 6 degrees of freedom per leg span the hip and knee and ankle for walking capability. The robot generates 244 Newton-meters of torque across these joints. Power comes from a battery providing 6 amp-hours with total running time of 4 hours. The C1 uses an onboard Intel Core i7 processor for compute. This powers a stereo RGB sensor array in the head, enabling depth perception and 3D environmental mapping. 9-axis IMU sensors in the legs provide real-time orientation data using accelerometer and gyroscope and magnetometer measurements. The projection display built into the robot's face allows it to share content for viewing or educational displays. The system also enables enhanced emotional expressions through visual feedback. Full color customization is available. At 28 kilograms, the C1 weighs significantly less than Boston Dynamics Atlas. At 80 kilograms or 176 pounds, Phybot positions the C1 as a humanoid companion rather than an industrial robot. Pricing for the C1 remains unknown. Industry estimates suggest a range between $5,000 and $10,000 based on comparable companion robots. The timeline for release is unclear. The company website does not list specific dates. Analysts expect possible availability in 2026 or later based on the development stage shown. The C1 does not feature hands in current demonstrations. The Phybot M1 represents a different category. This is a high-performance, general-purpose humanoid. The M1 stands 172 centimeters tall, or approximately 5 feet 8 inches. It weighs less than 60 kilograms, or around 132 pounds. The robot features 32 degrees of freedom distributed across its body. 2 degrees of freedom exist in the head. 7 degrees of freedom per arm provide manipulation capability. 2 degrees of freedom in the waist allow torso movement. 7 degrees of freedom per leg enable complex locomotion. The M1 features 5-fingered hands. The 32 degrees of freedom specification likely excludes the hand joints. Dexterity represents a key advantage over the C1 companion model. The M1 has dual arm load capacity of 20 kilograms or about 44 pounds. Backpack capacity reaches over 50 kilograms or approximately 110 pounds for loads carried on the robot's back. The M1 can carry up to 83% of its own body weight. Walking speed exceeds 2 meters per second. This equals over 6 feet per second or 4.5 miles per hour. This speed matches human jogging pace and exceeds most commercial humanoids currently available. The robot's peak joint torque reaches 530 Newton meters. Phybot claims this surpasses the power output of a Formula One race car engine. The torque capability comes from Phybot's proprietary FARC series quasi-direct drive integrated cycloid joints. These joints offer real-time position feedback and what the company describes as error-free execution. The joints feature an all-in-one modular design. The drive motor and reducer and dual encoders are integrated on board for simplified maintenance procedures. Runtime exceeds 2 hours continuously. The M1 uses 2 swappable batteries that can be hot-swapped within 15 seconds. This allows continuous operation through battery replacement without shutdown. The onboard computer is an NVIDIA Jetson Orin NX, providing 100 tera operations per second of AI performance. This computational power enables real-time neural network processing for the robot's perception and control systems. The M1 uses 3D LiDAR and stereo RGB cameras for environmental sensing. High dynamic range cameras provide additional visual input for environmental mapping. The robot employs self-developed motion control software integrated with its proprietary hardware. The control algorithms represent Phybot's internal development rather than open source or third-party systems. The M1 targets applications beyond home robotics. Industrial logistics represents a primary market. Service roles in commercial environments are also targeted. The robot stands significantly taller than the C1 companion model. The additional height and payload capacity position the M1 for tasks requiring human-scale reach and strength. Boston Dynamics Atlas remains the comparison standard. Atlas weighs 80 kilograms compared to the M1's 60 kilograms. This 25% weight difference affects mobility and energy efficiency. Lighter robots require less energy for movement and can operate longer on equivalent battery capacity. However, weight reduction can compromise stability and payload capacity if not engineered properly. Atlas has undergone years of public development and demonstration. Boston Dynamics has shown Atlas performing parkour and backflips and complex manipulation tasks. The robot navigates uneven terrain and climbs stairs and recovers from falls. This represents extensive validation of the platform's capabilities under diverse conditions. The M1 lacks comparable public demonstration history. Available footage shows basic locomotion and manipulation tasks. The robot has not demonstrated the dynamic movements Atlas performs routinely. This gap represents either conservative marketing or limitations in current capability. Without extensive testing data, direct performance comparison remains speculative. Pricing for the M1 is unknown. Commercial humanoids range from $10,000 for simplified platforms to over $150,000 for advanced systems. Boston Dynamics has not publicly priced Atlas as it remains primarily a research platform. Tesla's Optimus targets $20,000 to $30,000 pricing for volume production. The M1's price point will significantly impact market positioning. Release timeline remains undefined. Phybot has not announced specific availability dates. Industry observers estimate 2026 to 2027 based on development stage. Software platforms including operating system and programming interfaces are not yet specified. This suggests the robot remains in pre-production development. Several Chinese robotics companies are developing humanoid platforms. Unitree released the G1 humanoid demonstrating basketball handling, including jump shots and running shots. Questions arose regarding the authenticity of demonstration videos. If validated, the G1 represents another competitor in the humanoid space targeting athletic capability. The humanoid robotics market is accelerating. Boston Dynamics established technical benchmarks with Atlas. Multiple competitors now target commercial humanoid platforms with varying capabilities and price points. Phybot's M1 represents one entry in this expanding field. The M1's claimed advantages include lighter weight and higher torque-to-weight ratio and hot swappable batteries. These specifications suggest competitive performance if validated through independent testing. The robot's actual capabilities will be determined by field deployment rather than manufacturer specifications. Whether the M1 qualifies as an Atlas killer depends on application requirements. Atlas excels at dynamic movement and recovery. The M1 may excel at sustained operation and payload capacity. Different applications favor different capabilities. Industrial logistics requires endurance and load capacity. Research applications require dynamic movement and adaptability. The competition between Boston Dynamics and emerging Chinese robotics companies will drive humanoid development. Atlas established what is possible. The M1 and similar platforms will determine what is practical for commercial deployment. The technology exists. The remaining questions involve cost and reliability and market adoption. And if you liked the video, make sure to subscribe to AI Tech Academy and press the like button. Thank you for watching and see you in the next video.